So in this video, we're going to talk about two-way tables today. Two-way tables are tables that can be read both left and right and up and down, and they give two sets of information in a single table, and it's useful. It's basically a useful way to organize data that can be categorized into two variables. So obviously over here we have male-female data, and then we have how many siblings do you have. So that's what we're talking about here. For example 1, it says male and female students were asked about how many siblings they have. The two-way table shows the results from the survey. It says use the table to answer the following questions. So find the following for randomly chosen student. So first thing we need to do is we need to figure out exactly how many students were surveyed, right? So notice here we've got 3, 14, 12, 4, and 1, right? And so when we add the total to left to right, it's 34. And then when we add this total over here, we have 18 and 16, and that also equals 34. So it's a good way to check to make sure that you got your totals down here right and your totals on the right column correct, because both of those should add up to be 34. Okay, so then it says find the probability that a student has two siblings. Okay, so two siblings is right here. So we have a total of 12 students that have two siblings. So we're going to put that over our 34 number. So 12 divided by 34. And when we do that, that can reduce, if we divide both by 2, that would be 6 over 17. So that is the fractional form. And then if we then turn that into a decimal, that's going to be equal to 0.35, okay? And that is equal to 35%, okay? Now we could make that, and sometimes you might have some more points there, but for these, we're just going to round to the hundredth and then make that a percentage, okay? So the next one says the probability the student has 3 or more siblings, okay? So now when we talk about 3 or more, so there's our 3 total and there's our more total, right? So that's going to be 4 plus 1 over our 34. So that's going to be 5 over 34. Now 5 doesn't go into 34 at all, so that's as simple as that gets now. And notice what our answers are. They're in decimals, right? So we're going to divide the 5 by 34, and when we do, we get 0.15. So that's our answer right there, okay? Excuse me. The next one says the probability is female and one sibling, okay? So now we're looking for overlap here, guys. That's what we're looking for, because it's an and symbol. Remember, that's what we talked about yesterday in the notes. So female and one sibling. So let's look at female and one sibling. So when we do that, here's all our female, right, guys? We're going to do this like we did yesterday. And then our one sibling right there. Y'all got me? So where's our overlap? Y'all see it right here? It's the 6. So this one is going to be 6 over 34, which this can be reduced to 3 over 17. That's our fractional way of communicating the probability, and that would be 0.18, because it's 0.1765, and then that's going to be what? 18%. Okay? All right, so then the last one says one sibling or male. Okay, so I'm going to erase this up here so we don't get confused. One sibling or male. Okay, so when we do this, what we're going to have to do is we're going to have to add some numbers together, right? So we're going to count one sibling. That's all of this, right? One, okay, pen work, one sibling, right? And then male. So then we're talking about all of this right here, right? So notice that the 8 is represented twice. We can't count it twice, okay? So we can either count it in this 14 right here. But if we do that, then we have to then do 1 and 5 and 4 and 0, okay? So 14 plus 1 is 5, plus another 5 is, 14 plus 1 is 15. And then 15 plus 5 is 20, and 20 plus 4 is 24, right? So then we're going to do 24 over our 34, and that's going to reduce to be 12 over 17. Again, if we divide 12 by 17 or 24 by 34, you're going to get 0.71, which then when you multiply that by 100 is 71%. Okay, makes sense to everybody? Okay. So now here's example 2. So this one says, use the two-way table to answer the following questions. Now this is different in that we don't have all the totals. Notice that, okay? So we're going to work through this, and I think you guys can see what the total of the yeses is right here. We're going to add these two together to get our total. So that's going to be 0.78, right? Okay. Then to get our no's right here, aren't we going to do 0.7 minus 0.51? So that's going to give us our no's, because that's 0.19. And then over here for our totals, couldn't we do 1 minus 0.7? That would give us 0.3, right? So then we can figure out what the 0.27 is, what the no's are here, by doing 0.3 minus 0.27. That's going to give us 0.03. And then our total in the no column, we're going to add these two together right here. If we add those two together, we're going to get 0.22. Now, when you add these two, the yeses and the no's right here, when I add those together, I get 1. And when I add these two together over here, I get 1. And that's what it should be. Okay, so letter A says, give the probability of students with AirPods. And then it's got an accent. Y'all see this accent right here? See that? So it's basically asking us students without AirPods, okay? So the students without AirPods would be here we have students with AirPods and then students without AirPods. Students with AirPods not. Students with AirPods not. Okay, so that's going to be 1 minus our 0.51, guys, because that's a not. And when we have a not, we're going to subtract it from 1. So that's going to be 0.49, which is equal to 49%. Okay? So then our next one is going to be a person owns AirPods. Okay, so this is owns. Okay, so okay, so a person owns AirPods. How many people total own AirPods? So that's this right here, isn't it? That's how many people total. So that's 0.78, which is equal to 78%. Okay. Does adults and no AirPods. So here's all our adults right here. And remember, we're looking for AirPods and no AirPods, okay? So where's our no AirPods? It's here. So where's our overlap? You guys can see it. It's the 0.03, and that's equal to what? 3%, right, guys? There you go. Okay? So this is kind of like our Venn diagram when we're doing this, right? When it has and or statements, okay? So our next one says, this is a U-try. It says use the two-way table below to find each probability. Write each probability as a fraction, decimal, and percent. So what is the probability that you've been to Mexico, the probability that you've been to Mexico and been to Canada and Mexico, and then probability that you've been to Mexico or not been to Canada. Okay, so pause the video here. Come back to me when you're done. All right, so the probability that you've been to Mexico or someone's been to Mexico. Okay, so here's our probability, have been to Mexico. So notice here again, this is our total, guys. So that's always going to go in the denominator, right? So that's 25 as your denominator. And how many people have been to Mexico? Are 9. So this is 9 over 25. And when we put that in our calculator, we get 0.36. Okay, so our next one is been to Canada and been to Mexico. So we want, remember here again, we're looking for overlap. So how many people have been to Canada? These guys have been to Canada, right? But also been to Mexico. So also have been to Mexico are these guys, yes? So where's our overlap? Y'all see it? Yep, it's 6. So this is 6 over 25. And again, if I put that in my calculator, I get 0.24, which is 24%, okay? And by the way, this one here was 36%. Okay. All right. So the last one says been to Mexico or not been to Canada. Okay. So let's go ahead and erase this and see if we can figure this one out. So have been to Mexico is right here. Right here, have been to Mexico. Okay. And then it says have not been to Canada. Okay. So not been to Canada. Have not been to Canada. That's these right here. Okay. So there's two ways we can approach this problem. We could take our totals, our 9 over our 25, and add to it our 14 over our 25. Now the problem with this is we have repeated the 3 twice. Y'all see this 3 right here? We've repeated it twice. So we got to subtract it, 3 over 25. So that would be 9 plus 14 is 23, minus 3 is 20. So that's going to give us 20 over 25. And that reduces to be 4/5, right? Because, wait, 4, 5 times, yeah, 4/5. And that's equal to 0.8, which is equal to 80%. Okay? All right, so now there's another way to do this. Let me show you. So the other way to do it is when we circle those two things is just to count every unique number. So in other words, if we do it like this, where we have been to Mexico or not been to Canada here. So we just count all the unique numbers. 6 plus 3 is 9, and 9 plus 11 is 20, right? So it doesn't matter which way you do it when you have a table like this, okay? But you're going to see why this is relevant as we move through other types of problems as we move forward, okay? So, but that's our answer. All right, so here's your try 2. Go ahead and do this one and then come back to me when you're done. And I would go ahead, if I were you, and find these totals because it's going to help you guys, okay? All right, so total track was 40, 55 for volleyball, 45 for basketball. I got 28 for tennis, and I got 272 for no sports. Okay, then I'm going to go across and do my grades. So grade 9, I got 120. 135 here, 100 here, and 85 here. So to double check your totals, you're going to add your vertical total and your horizontal total. Okay, so when I did both of those, I got 440. So this is our grand total down here. So anytime we're trying to find a probability, we're going to put it over that. Okay. So it says rewrite each of these probability statements with correct symbols and then find the probability. So what's the probability that a student is in grade 10 and does no sports? So because you see that and term right there. So we're going to say the probability of 10 and, remember that's our and symbol, no sports. Okay. That's how we rewrite it. Okay. And I want you guys to do that for practice. All right. So, this is an and statement, so we're looking for overlap, right? So let's look at grade 10 right here. Those are all our grade 10s, right? And then no sports, right? So here's our no sports. So how many did we have in grade 10 and no sports? That number right there. Y'all see that number right there? Okay, pen, change for me, please. Right there, that. So this is going to be 95 over what? 440, okay? I can reduce this 95 over 440. And when I divide both of them by 5, I get 19 over 88. And that also is a decimal. 0.22, and that's 22%. Okay? Then it says find the probability the student is in grade 10. Okay? So I'm going to go ahead and erase all this right here that I had because I don't need it, right? So grade 10, that would just be this 135 right here, right? Over what? 440. 135 divided by 440 again. If I divide 135 by 5, I get 27. So that's going to be 27 over 88 simplified or reduced, right? So this time That's 0.31, which is 31%. Okay? So then letter C says find the probability that a student runs track or is in grade 10. Okay, so this is an or statement, okay? So once again, if it's probability that runs track, so here's our track numbers, right? And then it says also what? Or in 10th grade, okay? So this time, remember, we're going to combine these values, okay? So here's the thing. We can add the 12, we can do this 40 right here, but we can't add the 6 twice, okay? So we could do it, like I said before, we could do the 40 over the 440 plus, so that was this number down here when we added that column, and then we could do the 135, so then we could do the 135 over 440 as well, but then remember we got to subtract that 6 because it's repeated twice right now, right? So we have to subtract that 6 over 440. So when we do that, we get 169 over 440. And let me see, 169 divided by 440, math 1, that doesn't reduce, okay? So then that's equal to 0.38, which is equal to 38%. Now remember, the other way to do this is just to count all the individual numbers, right? So you could do 12 plus 15, 12 plus 6 plus 7, 12 plus 6 plus 15 plus 7 plus 20 plus 12 plus 2 plus 95. You could do it that way as well. Either way, you're going to get 169, okay? Let's find the probability of 10th grade and track, okay? So, you know what I forgot to do up here, y'all? I forgot to write this one as an or statement. So let's go back and do that right here. So the probability of track or, and that's our U, right? 10, okay? So then this one is just probability of 10, so we don't have to worry about it. The next one is the probability of 10th and track, okay? So I'm just doing this to get you guys in the habit of knowing what the symbols look like, okay? So this time it's and, so what are we looking for? We're looking for overlap again, right? So let's look at 10 and 10th grade and track. So here's our 10th grade right there. And then here is our track, right? And so what's the overlap? That's what we're looking for. That's 6 right there. Y'all see it? So this is just going to be 6 over 440. And when we do 6 divided by 440, again, you could probably see that 2 goes into both of those. So this is going to be 3 over 220 reduced. And then when we divide 3 by 220, that's 0.01, which is 1%. Okay? So letter E here says find the probability that a student is in grades 11 and 12 and plays basketball. So we're looking for the probability that the student's in 11 and 12 and plays basketball. Okay, that's what it's asking us for in this problem. So that means we're looking for overlap of all 3 of these things. So let's go up here and erase this. I don't even know what that was, y'all, but so grades 11 and 12, look here, guys. Grades 11 and 12 don't have any overlap, do they? So I can already tell you we can't answer this question the way it's written, okay? And then it says 11 and 12 and plays basketball, right? So there's our basketball people that overlap, right? But 11 and 12 don't overlap. So let's rewrite this question just so we can answer it. So if this was the word or, then we'd be good because then we'd be looking for the probability of 11 or 12 and play basketball. Okay, now we have one big group, right? So we're going to combine the 11 and 12. So let's do that. So now we have the groups. Let me see if I can erase this the rest of the way. Okay. So now we have the groups 11 and 12, right? So those are now combined, right? And how many basketball players do we have in that group right there? So that's going to be, we're looking for our overlap. What's the overlap? 8 and 10. So that's 18, right? So for this, so this would have been, it's impossible. Y'all got me? So no answer. Or what? 0%, right, y'all? Okay. All right, so if we look at the other one, we have the 18, right? So we have on this one 18 over 440. So that's going to be equal to, we can simplify it to 9 over 220, right? Or 0.04, which is equal to 4%, okay? This last one says, find the probability of ninth and no sports or tennis. Okay, so let's see about this one. So ninth grade, so let's go ahead and erase this so we can see it again. So I'm trying to get you guys to visualize this every time we do it. So ninth grade is right here, right? And then it's saying no sports or tennis. Okay, so we're going to look for the overlap here of no sports and tennis. So no sports and tennis, that's a combined group because it says or, right? So that's these two groups, okay? So where do y'all see the overlap? Right there. Do y'all see it? So we're going to do 9 plus 66. Let me erase that. I don't know what that was, y'all. So we're going to do 9 plus 66 over 440. That's going to be 75 over 440. That reduces to be 15, because 5 goes into both, over 88, which, if I put it in decimal form, that's 0.017, which is 17%. There we go.